Hey, good afternoon, everybody. We'll get started with our next session here. We're going to talk a little bit about NVMe over Fabrics boot and NVMe over Fabrics booting with TCP IP is real. It is now an actual thing that you can buy today. You may have already bought one or two or more and not even know it. We have had updates in this conference before, but it's always been in the lab phase working on things that you couldn't buy yet. But now we're past that, and if it'll let me move to the next slide here. There we go. Okay. Quick agenda there. We're just going to give you a little bit of a brief overview of what led us today, and then Doug is going to lead you through the actual being able to use it. So real quick, why is it important to be able to boot from NVMe over Fabrics? The boot functionality that we're talking about today has been developed by NVM Express in the boot task group. That's a healthy group with 41 active member companies participating, a core set of companies actively developing things, and a large group of people that have been contributing and reviewing the spec. The first specification was released in November of 2022, about 2 years ago now. That was used for a lot of development effort, and during that development effort, we found a number of things that were improvements that we could do in the specification, and we created a 1.1 specification, which went out just about a month ago, that has changes that are entirely come from actually community feedback during the development. But why were we doing this? The big reason that we're working on this is that it's another step towards our composable world, with everything composable, being able to use common components and network management and compose things. It furthers treating your computers and your data center as cattle, not pets. Don't have to customize each and every system anymore. So that lets you have some modern orchestration and really enables the diskless and ultimately stateless compute industry. And we've had some questions. What about if I want to have a disk in my computer to use for instance storage? The NVMe over Fabrics boot functionality is completely compatible. It can coexist with instant storage. It just lets you move your OS image to a centralized remote location instead of having to have a customized boot drive in every single system. Here's a quick snapshot of the NVM Express boot group. It is under the NVM Express organization. You can see the NVM Express organization structure there, and boot group is that cool little purple box down there at the bottom. Don't you wish you had your own purple box? I won't go through all of the individual companies here. I'm sure we could elaborate on the great member companies, but you guys probably get bored and leave me. There is code that has been implemented to use the NVMe over Fabric specification. That was implemented by an organization that's called the Timberland SIG, as a special interest group formed specifically to partner with NVM Express and develop a reference implementation for NVMe over Fabric TCP boot based on UEFI. So it says that we did partner with NVM Express, and there's a link down there at the bottom for where the GitHub location is for the Timberland SIG. All of the code that we developed is publicly available on that site now. And everything that was created is based on the NVMe-oF 1.0, or the NVMe Boot Spec 1.0 for the Fabrics booting capabilities that are defined in that spec, and using common open source frameworks. It was developed by a subset of the member companies. The core contributors are shown on your screen here. Dell, NVIDIA, Intel, SUSE, Red Hat, HPE, VMware. Good cross-section of companies that are building real stuff that many of you have in your data centers today. And most of that work today has been released and upstreamed under the BSD3 clause and a few other open source licenses that we're required by their individual source components. So many of the applications that are required for making this work, the upstream versions have everything built in today. So a little bit more on why is it important to boot from Fabrics today? Why is it more important than it was a couple of years ago? Like I said a little bit ago, the composable world that we're living in today, there is a lot of interest in being able to have reusable building blocks that are composable with remote orchestration. Diskless servers without a boot operating system on those servers are much easier to manage from a centralized administration console like we're showing in the graphic here. You can maintain here at your DevOps centralized location without going out and customizing each one of a different set of servers. That gives you at-scale solutions for remote management. Frequently, it says possible, but I think virtually always there are OpEx and COGS savings by that centralization. And you can have immutability with systems booting off of a common golden base image. And it enables your platform CI/CD and lifecycle management using Redfish. Everything that we've implemented has been integrated with Redfish, so you can pre-build your images and not customize the full deployments at the last mile. You do that before the reboot and then move your bits only as necessary to boot your systems. But how can you actually use it? Please, we've got Doug with us here today, and he is going to tell you about how easy all this is.
Yeah, thanks, Curtis. Hi, everyone. I'm Doug Farley. I'm a distinguished engineer with Dell, and I'm one of the co-chairs of the Boot Task Group. So, as Curtis led off, it's real. There's systems that have been shipping for now over a year that are capable of NVMe over Fabric boot. Really what you need is a modern system with UEFI BIOS and the boot extensions and Redfish integration. And, from there, once you have a platform image that you want to boot, it's only 3 commands. It's that simple to really get started. We're going to go through it in real brief here. In the backup of this deck is a line-for-line set of steps that you need to go implement and test your own at a home lab to get going. We don't have time to drain that in this talk, but we are happy to talk to you about it. But in short, we're going to start from just an off-the-shelf OpenSUSE Leap image, pulling it down right from the website, quickly customize the thing, and then boot it. And you can take this same recipe, scale it into your CI/CD pipeline. I have it in my CI/CD pipeline, and spit it out and have every image auto-mounted to your test systems with Redfish and go from there. And as Curtis said, you get full immutability then. Those 3 commands, the only 3 things that we have to do to enable that on a modern system: patch our BIOS attributes with the target parameters for our target and our host, schedule and activate job in your Redfish instance, and then kick off scheduled jobs. Those are the 3 commands. Now, you'll notice the target is just pointing at a subsystem that already has my disk exposed. So there's some infrastructure of a service, work that has to be done up front to make sure that your target has the image, but that's just a product of your CI/CD pipeline. That thing just gets staged into a remote image, and then you just need to point at it to boot. So where do we go from here? As Curtis said, we just released 1.1. 1.1 was entirely based on community feedback. All of our friends and implementers that experienced turbulence with their qualification, they experienced things that they wished were better. That's what drove 1.1. We're not going to drive another dot-numbered one without more feedback as well. Primary content in 1.1 were things around like DHCP modernization so that we could better handle customers who had big dynamic fleet deployments and needed to have, better IP management in their instances, better error code resolution when they had network problems or storage access problems and they wanted to debug what the trouble of that was in their remote instances. And then largely, better clarity in our examples. You know, a big thing in the NVMe Boot spec was we wanted to have a big appendix of examples of how do you implement and use the thing? What are the fields meant to do? How are you meant to interpret them? And there was a lot of clarity that we had to drive back in 1.1. As I said, one of the big things that we need out of the boot spec is involvement from the community, because the ecosystem is very complicated. There's a lot of different variations in the Linux OSs. There's a lot of variations in all the other supported OSs out there in how they approach, their, configuration management, their change management, how they want to attach to subsystems. That type of interoperability requires everyone to participate. If you want more features like authentication support or, enhanced discovery or new transports, we got to have your participation. We'll continue to work on these things incrementally, but it's better if everyone has this level of interest. And then lastly, and back up here, we'll have links to all of the collateral of how to set all these things up, how to utilize them. Some of the major touch points from the boot spec were both over in UEFI and ACPI specs, and then a whole bunch of open source repos that were touched. UEFI EDK, SPDK, EFI Boot Manager, Drake-it, everywhere. That's really it. Yeah, we've got a few minutes. Did people have questions, or you want to see? Yeah. Yeah. So, what's that? Oh, yeah. So the question was, can we characterize the changes in EDK2? For EDK2 in Timberland, we have a branch that still hasn't been fully upstreamed into EDK. That's effectively a NVMe over TCP driver. So it's a TCP protocol implementation for doing NVMe over Fabric's TCP as a protocol layer, and then a separate protocol for populating the NBFT. The NBFT is it's a configuration table to be passed in ACPI space between the pre-OS to the OS environment, and contains all the context. The majority of the boot spec is a definition of how a driver in the pre-OS environment needs to populate the contents of the NBFT so that an OS can read it in a standard way and understand how to interpret it, and vice versa. So that almost the entirety of the spec is focused on how do we, do that common interchange. And so the EDK2 support is in the two areas of driver support for just doing fabrics, and then knowing how to write a NBFT. Yeah, absolutely. So that's kind of an OS dependent. So sorry. The question was, what's the scale of NVMe over Fabric's boot look like on a network, and what do boot storms look like? So it depends. It depends on how big your boot environment for your OS is. If you use say, let's pick on OpenSUSE's minimal image here. The initRD is on the order of like 1.5 MB. The kernel is like 3 megs. So, you can hit an impact of having to pull that in with. We can't avoid those bytes. They got to move over the network. So you'll see that for sure. Beyond that, it depends on what you're doing to your box. Again, with a minimal image like this OpenSUSE image here, there's not a lot that's done, back I/O during post-root switch to the file system. So after that initial, 4 or 5 megs, you don't really see any traffic. There's ways we can go thin that out, and we can go optimize images for this type of transport. But you're always going to hit that initial burst. Okay, just walking through the steps of what what it takes to go build one of these images. Most of the work that you have to do is around image curation. I mean, this is like a CI/CD pipeline. We start off here just grabbing the OpenSUSE minimal image, but if you're familiar with tools like Kiwi or something else, you can just instrument that up out of your CI/CD pipeline and have that as an artifact in place of this fetch step. From there, we loaded it up in QEMU to just go modify it and add in the parameters we care about. Really, the parameters we care about are adding in NBFT support into the init RAM. The OpenSUSE minimal image is minimal. It does not have NVMe CLI. It doesn't have any of your host drivers. So in this case here, we needed drivers for our network card, and we needed NVMe CLI in order to be able to do NVMe over Fabrics connectivity. So you had to add that in. Once that's in, you're ready to go. Like that's all that's needed. Yeah.
I've noticed that you have the no-knock driver, the venue, and the nice driver. Are the other two drivers you need, or are they for this working at all on any platform?
No, these were just drivers I needed for my platform. I was just showing this on a Dell R760. I had both of those in there. Oh, I'm sorry. Yeah, so the question is, are NVMe Fabrics and NVMe TCP required? Yes, for this version of Drakit that I'm using, the one that ships in 15.6, it does not automatically pull in NVMe Fabrics and NVMe TCP. There is bullet number 4 here. There's a PR that just merged upstream to automatically pull in NVMe Fabrics and TCP now. The trickle-down effect will eventually hit the distros. Those are gotchas you'll have to pay attention to. Another fun gotcha in loading up something like a minimal image into QEMU and trying to build your init RAM. Well, it probably doesn't have any of your firmware files, and it didn't auto-detect the firmware of your HBAs, so you're going to have to force those in too. But once you know what your platform is, if you can have more homogeneity in your fleet, then you can treat them more like cattle, and then your CI/CD pipeline can just spit this thing out, be pre-customized for your environment. But it's certainly a catch. What else here? So the next step is just pre-orchestration for this, because I'm just using kernel NVMe-T to just show you this demo. So we're just going to show that we can loop mount the raw image that we've now customized. We're going to go fire up good old NVMe-T in the kernel, and you just need to make sure that it's got the right parameters to point at the raw image that you used, and it's got the IP address of itself for its subsystem, and you need to get your subsystem NQN correct. And you can see there it's running, and now it's reporting properly. And then from there, we're just going to go configure our victim server. In this case here, I'm using the slot 3 port 1 adapter. So, if you're doing this at scale, API integration with your IPAM, probably going to be an important thing to consider. And then, again, the 3 commands for setting your BIOS attributes, point your server at it. Maybe a 4th command to go, reset your boot order if you had multiple things. Like if you have instance storage, most systems, especially EFI Boot Manager, like to append things. So you might want to go keep that in mind. Not mandatory if there's no, bootable ESP on any of those drives. But if you're trying to dual boot for a test, probably going to get in the way. From there, like on my victim server, the system will then reboot and go into configuration cycle, deploy the new BIOS config, reboots into Grub. This is Grub loaded across NVMe over Fabrics. This isn't like Grub locally. And then we're booted into working instance. And you'll see that the adapter, so this is the change that we made upstream in Drakit, is that Drakit will relabel the device as an NBFT device, because if that thing gets touched, you lose your root file system. And then from there, you can do good old NVMe list. What I don't have on here is you could have run NVMe show NBFT or NBFT show. It'll also dump out the NBFT from NVMe CLI. That's it.
You mentioned on the updates.
Yeah.
DHCP integration there.
Yep.
I noticed this thing doesn't include the server component or anything like that. Would your demo be differently?
So DHCP actually was, oh yeah, so the question was, thanks. The question was, DHCP, there were DHCP updates in 1.1 spec. What would have changed in the demo with DHCP? Well, so 1.0 actually had support for DHCP. It just didn't have great support for communicating things like client identifiers between the pre-OS and the OS environment so that you could synchronize those two things and get the same result from your DHCP server. That was a big change in 1.1, was navigating that whole space for IPv4 and v6. For the demo, the only thing that would have had to have changed is we would have, instead of setting the address on the host, you would have had to have had a DHCP server, of course, set up with your MAC address for the system. But we would have just not populated the IP fields for the client. It would have auto-configured it. It would be annotated in the NBFT appropriately, and Drake it already today knows how to read the NBFT for DHCP information, and with the changes in 1.1 would be able to reissue the same exact ICID and DCID. Any other questions? For anyone who's also doesn't have one of these servers to play around with, as Curtis pointed out, up on Timberland SIG, we have all of our reference code, including the, build your own sandbox with QEMU. So there's code for both Red Hat and SUSE up there. And I believe Canonical just released theirs as well. So you can build your own client and server sandbox complete with QEMU there as well, leveraging all this.
Probably say what servers have for HPE Gen 11 servers.
Yeah. So HPE Gen 11 and Dell PowerEdge 16G and beyond all have support. It's host side only. There's no storage array support. Your storage array or your storage subsystem just needs to support NVMe or Fabric TCP. There are no specific adapters required either. It uses the EFI UNDI driver by default. So if you can already PXE or you can already HTTP boot or whatnot, you're good to go. So we got. Anyone else? Cool. Thank y'all.